Okay, I start. In previous lecture, I told you if you have a bounded sequence and increasing, then it converges to least upper bound. Or you can say, suppose it is increasing, so if it is sufficient to prove that it is bounded above, because this is increasing, so obviously it will be bounded below. Then it converges to its upper bound, least upper bound. Same thing is here. If you have a sequence which is bounded and decreasing, then it converts to its greatest lower bound of the set Xn such that n is the element of n. Now, we use these theorem to check the convergence of a particular type of recursive particular type of sequence which is known as the recursive sequence. What are the recursive sequence? Recursive sequence are those sequences whose nth term is defined in terms of the previous terms. So first I am writing the definition. Sequences whose nth term is defined in terms of previous term. And terms, all terms, second terms, third, yeah, and term are called recursive sequence. For example, take first example. Let x1 is equal to square root 2 and x n is equal to under root 2 plus x n minus 1 for n is greater than. So this is a recursive sequence. First is this. Yes, Gaurav. This is x1 square root 2 and all the terms for n is greater than x2 is written in terms of x1, x3 is written in terms of previous term, that is xn. So this is a recursive sequence. Now question is xn convergent? So now if you recall your definition of convergence, it is little bit tricky. If you cannot use limit sequence theorem or sandwich theorem, sometimes it may apply, but normally if you use this previous theorem, bounded and monotone, then you can easily prove, easily check that the given sequence is convergent or not. So I am proving, so solving this problem, x1 root 2 xn is equal to 2 plus xn. Here if you see x1 is root 2, xn is equal to under root 2 plus xn minus 1. So it is increasing. It is looking like increasing. So first I am checking, is it increasing or not? So this is an idea that it may be an increasing sequence. So let us prove, check. It may not be, but we need to check increasing. So I will apply mathematical induction method. Induction. So increasing, yes. Write on the chat box. Any doubt? No. So here you can see 2 plus root 2 is greater than 2. Take square root 2 plus root 2. This is root 2. So here this is actually x2 is greater than x1. So result is true for trivial. Let xn is increasing for n is equal to k. Now you need to prove for n is equal to k plus 1 if it is increasing. So here we have, if it is true for k, so xk will be greater than xk minus 1. Add 2 both sides. Take square root. So this is 2 plus xk, 2 plus xk minus 1. So here you can write xk plus 1 is greater than xk. So it is true trivial, x2 is greater than x1. You assume, suppose this is true for k, and now you have proved that this is also true for k plus 1. So you can say xn is increasing. Now, if you want, we have proved that this is an increasing. Now, you want to prove that this is bounded. Then you can say this series will converge to its limit. So that is boundedness. Clearly, xn is greater than 0 because all are positive. X1 is equal to root 2 and this is. Now, we claim, now question arise, what may be the upper bound? So if you see the question, x1 is equal to root 2, xn is equal to 2 plus xn minus 1. So here x2 is equal to 2 plus root 2 like that, and this will be like that, root 2 plus root 2 plus root 2 like that. So if you recall in intermediate, sometimes it may be bounded by 2. This is an idea. Okay, this is an idea. I am not saying this is bounded by 2, but I am getting some observation. It may be. So we claim, let us say, suppose I want to prove that this is xn is less than equal to 2 for all any natural number. Now you need to prove it. So by mathematical induction, clearly x1 is less than 2. Now, suppose result result is this: action is less than true is true for n is equal to k. If this is true, so it will be xk is less than equal to 2. Now add both side by 2. So this will be 2 plus xk is less than equal to 4. Take square root. 2 plus xk is less than equal to 2, or this is xk plus 1 is less than equal to 2. So you can say xn is bounded. So this is bounded and increasing. So you can say, so sequence xn converges to converges. So sequence x1 and converges, and suppose it converges to L. That is, you can say limit n is tend to infinity, xn is equal to L. Now be careful. If you write limit n is tend to infinity, xn is equal to L, or this is same, x n minus 1 is equal to L, or you can write limit n is tend to infinity x n plus 1 or 2, this is well, because if n is tend to infinity, then n minus 1 also tends to infinity, n plus 1 n plus 2.
Sir, please explain the bounded part again.
Part of
Bounded part, sir.
bounding. Here, if you clearly xn is greater than equal to 0, okay. Now idea is it may be bounded by 2, because this is 2 root 2 plus 2 root 2, so this is an idea, it may be. So I try to prove by mathematical induction. So clearly x1 is less than 2. Okay. Now suppose it is true for k, n is equal to k, so xk is less than equal to 2. So here expression is, I need to write 2 plus xn. So add 2, 2 plus xn is less than 4. Take square root, this is 2. There cannot be negative because all terms are positive. Xk plus 1 is less than equal to 2. So by mathematical induction, you can say this is xk. So here finally, what you are saying? Okay, xk is less than, so xk is bounded by, upper bounded by 2, and this is less than equal to 0, greater than equal to 0. So you can say sequence xn is bounded. So you have a bounded sequence which is increasing. So you can say this is converges. Suppose it converges to L. You can write. Now, any doubt, Karthike? Okay?
Yes, sir.
Sir,
Yes.
sir, we have assumed that xn is less than true for n equal to k.
Uh, we didn't assume. We claim. I want to show that it is xn is less than 2. It is bounded by 2.
Oh, okay, okay.
Claim is we are going to prove. So
Okay.
now you want to find the limit point. Xn is equal to 2 plus xn minus 1. Taking limit both sides. Taking limit both side as n is tend to infinity. So this will be limit n is tend to infinity xn limit n is tend to infinity 2 plus xn minus 1. So this will be L. under root 2 plus L. If you solve this, take a square and do the factor, the answer is coming L is equal to L is coming 2 and minus 1. Minus 1 is not possible. So limit n is tend to infinity, xn is equal to 2. So this is the solution of your problem. If anybody has doubt, ask me. No. Now
Sir,
I move on here. 2 is supremum or not?
sir,
Chirag, 2 is supremum or not? Check it. I am saying this is 2 is the supremum. This is your homework.
sir,
Why
can
I
you please
the supremum? Please write on the chat box. Why I am saying 2 is the supremum? Because theorem says if a sequence is bounded and increasing, then converges and converges to its supremum. So if 2 is the limit, so 2 must be the supremum.
Sir, how we claim that xn is less than 2?
How we claim? Okay, I have told the answer of this already, but I am explaining again. This is an idea because sequence is written like that: root 2 plus root 2 plus root 2 plus root 2. So I am guessing 2 may be the upper bound. This is an idea. You have seen this type of problem in intermediate also. Otherwise, no idea. You can, if you are able to prove, you can prove this is n is less than equal to 3. That is okay. If you are able, xn is less than equal to 4. But if you take 2, because 2 is the supremum, you can easily apply the mathematical indexing. Harshit, you are saying, explain why limit n minus 1 tend to infinity. See, if n is tend to infinity, then n minus 1.
sir, I am asking why xn
Because-
minus 1 equals to L.
Wait. If n is tend to infinity, if you subtract minus 1 both side, n minus 1 infinity minus 1, this is infinity. It doesn't mean if you subtract any quantity from infinity or add any quantity from infinity.
सर xn minus 1 equals to L क्यों हुआ? मेरे को एक बार जानना है.
Actually, what is the mean of limit? Limit says if you have xn, it tends to L if n is tend to infinity.
Yes, sir.
So what you are going, suppose you have n is so large, it is going infinity, so terms are approaching to L. So if you write like that, x minus 1 is tend to L, if n minus 1 is infinity. If it is in million, trillion up to infinity, अगर आप एक
Okay,
नंबर
sir.
कॉपी कर लोगे तो क्या फर्क पड़ेगा?
Okay, sir.
Okay. Any other
Yes, sir.
doubt?
सर ये पार्शियल लिमिट तो नहीं होगी? लिमिट अंडर रूट 2 प्लस एक्स एन माइनस 1 में अगर मैं लिमिट सीधे अंदर ले जाऊंगा तो ये पार्शियल लिमिट तो नहीं हो?
Partial limit mean?
मतलब पार्शियल लिमिट मतलब
This is the property of the limit. You can take inside.
नहीं, पर वो होता है ना कि यदि कोई एक्सप्रेशन है और उसमें एक से ज्यादा टर्म्स हैं और मैं सीधे बाकी टर्म्स को नेग्लेक्ट करके सीधे n किसी एक पर्टिकुलर टर्म में बाकी n को छोड़ के किसी एक ही n को इंफिनिटी टेंड करवा देता हूँ तो पार्शियल लिमिट कहलाती है.
Don't go on that direction. Only the limit, if you limit it will be like that. Don't
Okay,
confuse. only I am 2 plus limit n is 10 to infinity x n minus. This is all.
Okay. Okay, sir.
Okay.
Thank you.
Sir, if
Thank you, sir.
possible, please take one more example. Or
Manan, I am not taking more than one example because syllabus is too lengthy. I have given it, I will give you the problem in the assignment
Okay, sir.
and discuss.
Okay, sir.
Subsequence. What is subsequence? First read the definition what I am writing. Let an be a sequence. Okay. Let an be a sequence if n1 and 2 are positive integers such that nk is less than nk plus 1 for all k is the element of n. Then there will be a sequence A and K whose terms will be A and 1, A and 2, like that, is called subsequence of an. First read the definition. An be a sequence. N1 and 2 are positive integer in increasing order. Greater than this is for all k. Then a and k whose terms are an1 and 2 and k, this is called the subsequence of an. First I am doing one example, then I will do more things on subsequence. Suppose you have an is a sequence 1 by n, which is you can write 1 by 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, like that. If you consider nk is equal to twice k. You take here, it will create some little bit, you may confuse. Here I am writing for your understanding only 1 by twice k. So here if you take nk is equal to 2k, so what will be the sequence? A and k. You can write this will be A to k. So what will be this? K is equal to 1, 2, 3. This will be A2, A4, A6, A8, like that. Or what is it? A2 is here A2 1 by 2, A4 1 by 4, 1 by 6, 1 by 8. This is a subsequence. So you can write A and K. So A and K is a subsequence. of a k, or you can write in this form little bit. So a n k, yeah, you can write this is a twice k. Now if you consider another, I am giving the one more.
Excuse me, sir.
Just wait. Just wait. If you consider nk is equal to twice k minus 1, where k is the element of n. So what will be a and k? A twice k minus 1. So terms will be this: a1, a3, a5, like that. This is equal to 1 by 1, 1 by 3, 1 by 5. So again you can say a n k, which is equal to a 2k minus 1. This is a subsequence of a k. One more point here, in these two examples, nk
Sir,
is
subsequence of AN or AK?
just wait 5 minutes. I want to complete, then I will answer all your question. Just wait. Or Gaurav lagging, or I am speaking slowly. My voice is clear or not? Anybody can tell?
It's clear, sir. It's clear.
Okay, I will speak slowly. Here, in both these two questions, 1 and 2, nk is always greater than k. Here you can say nk is equal to 2 if k is equal to 1, nk is equal to 4 if k is equal to 2, and so on, like that. Here nk is equal to 1 if k is equal to 1, and k is equal to 3 if k is equal to 2. Are you getting point? So it means what you can say, nk will be always greater than equal to k. So you can say it is clear that nk is greater than equal to k for all k is the element of n. So it means you can say if k tends to infinity, obviously nk will tend to infinity. Okay. Now I am doing next example. I will take the problem of all of you. Just wait. Now example 2. Suppose you have a sequence. Can you say every sequence is the subsequence of itself? Every sequence is the subsequence of itself, as every set is the subset of itself. Here, what will be the nk? If you take nk is equal to k, same. For all k is element of n. If you take same nk, it will be a subsequence. Example 3. Suppose you have a sequence ak. This is equal to 1 by k. Same thing, 1 by 1, 1 by 2, 1 by 3, 1 by 4, like that. Now consider a sequence. you consider a sequence whose terms are this. You take this is suppose this sequence is you take, you can write Bn. Terms of these are 1 by 2, 1 by 1, 1 by 4, 1 by 3, 1 by 6, like that. So here question is Bn subsequence of AK? Check. Here Nk, so N1, what can you say? N1 is equal to 2, N2 is equal to 1, N3 is equal to 4, N5 is equal to 3. Because this is Bn is actually Bn 1 by n, like that. 1 by n. So here is actually is subsequence. So I am writing in terms of subsequence n1, n2, n3, n4. If anybody has confusion, so I can write in subsequence. Suppose you have B and K. This is written in this. So B and K means here is changing. So 1 upon Nk is this. So Nk here is 2, and 2 is 1. And 3 is 4 and 5 is 3. Is it subsequence? No, because N1, N2, N3, N4 should be in increasing order. So B and K, whatever sequence is not subsequence, since Ni are not increasing order, are not in increasing order. Now consider another sequence. Consider another sequence, sorry, not subsequence. Suppose this is, you can write again B and K. Yeah, B and whatever, this is the only symbol. This is 1 by 1, 0, 1 by 3, 0, 1 by 5. Is it a subsequence? Again, 0 is not element of An. 0 is not element of N. So again, this B and K is not subsequence of sequence An. Since 0 is not in the element. Since there is no 0 term in An. So this is the examples of the subsequence of a sequence An. Now if anybody has doubt, ask me. I think most of the doubt have been cleared.
Sir, can we say that in this B and K sequence, since this is not an increasing sequence, इसलिए भी ये नहीं है
Yes,
उसका.
you can also say this. This is not increasing, that's why. Not increasing, not. Terms should be in increasing order. N1, N2, N3.
Yeah, मतलब the NK terms are not increasing.
Actually, I gave these two examples. In one, the 0 is not element. So it is compulsory in the subsequence that all element must be from the parent sequence.
Okay, sir.
And second, these must be the increasing order.
Okay.
That's why I consider here 0. Any other doubt?
Sir, please scroll up to the example 1.
Yes.
Please scroll up to the example 1.
Here, this is okay.
Example 1.
Okay. Okay. Now here, this is.
Sir, here AK is equals to 1 upon 2K.
Yes.
So the elements you are written, I think they are wrong.
Why?
So if you put K equals to 1, then first element will be 1 by 2.
So I think this is 1 by 2.
No, sir, but AK is equals to 1 upon 2K. So
Oh,
sequence will
okay.
be like,
Yeah. You are right. This is typing. This is 1 by.
Okay.
This is
Yeah.
typing. You are right. Because here is written 1 by 2, so this is 1 by K. This is typing. That's why I told you, don't go blindly on my notes. There may be a typing error. If you have any doubt, see the books or ask me.
Excuse me, sir.
Yes.
So please scroll up to example 1, second part.
Problem 2, example.
Sir, example 2, second part.
Example 2.
Second sequence.
Example 3, I think.
No, sir, example 1. Example 1. Sorry.
Okay. Example. Yes. Here. Example 1. This is. Second is this.
Sir, scroll
Sorry.
a bit down.
So I am doing. This is.
Wait, sir, wait. Sir,
Yes, same doubt.
sir, ye,
But it is not an
It is-
element of an, it only tends to 0. Khusigar with but an converges to 0. Yes. Chirag, Khusigar, I am not talking about the convergence. Here, 0 is not element of the parent sequence, that is an. So I want to say that every element of the subsequence must be an element of this an.
यस सर, वो चिराग कह रहा था कि एएन जो सीक्वेंस है उसमें भी 0 आ ही रहा है क्योंकि इवेंचुअली
कौन
वो
कह रहा है
कन्वर्ट 0 को हो रहा है.
Who is saying?
इसलिए मैं कह रही थी कि 0 उसका एलिमेंट नहीं है, सिर्फ वो वहां तक टेंड करता है.
Okay. 0 is not the element. I think Chirag, it is clear.
सर
Yes.
हाँ तो सर ये इसमें लिखा हुआ है ना, इट इज वो K belongs to R लिखा है सर आपने. इट इज क्लियर दैट.
Where बेटा?
सर ये यहाँ पे है, ये आपने स्क्रीन प्रेजेंट कर रखे हो ना. हाँ सर यहीं पे. इट इज
It is
क्लियर
clear that nk.
greater than equal to K for all K belongs to R.
Oh, sorry.
natural-
This is typing. R तो हो ही नहीं सकता. We are working in natural number. Sorry, sequence.
सर ये टर्म्स के लिए कोई स्पेसिफिक पैटर्न फॉलो होना जरूरी है या फिर इंक्रीजिंग है तो भी चलेगा?
देखिए, definition must be true.
Okay.
Definition says if this is not increasing, terms are must be in increasing order. It means what it wants to say. Suppose you have A1, A2, A3, A4, A5, A6, A7 infinite. So what it says, you are taking terms here. ये ले लिया, ये ले लिया, ये ले लिया, ये ले लिया. Like that. ऐसे नहीं है कि पहले ये लिया, पहले A3 लिया, then A1 लिख दिया. It cannot be in subsequence. A4, फिर A8 ले लिया, फिर A9. Now these cannot be the 2, 1 cannot be in this. They will be in order and increasing order. Clear point?
Yes, sir.
Sir, is nk always greater than k in every subsequence?
Yes.
Okay, sir.
जब you are taking terms from an, तो या तो equal होंगे. If you are taking every sequence in the subsequent itself, otherwise greater than होंगे. Clear or not? Should I tell you more?
सर इनके को k/2
One more example.
k/2 कैसे लोगे बेटा?
सर तब भी तो n
एक
के
मिनट, एक मिनट, जस्ट मिनट. You have AK. What is this? A1, A2, A3, A4, A5, A6, A7, A8. Actually, K is clearly telling the position of the element. अगर आप, if you take any sequence and K, you are saying sir k/2. So what will be the terms of sequence A and K? A1/2,
Okay.
A1, A3/2. कोई है ऐसा एलिमेंट पोजीशन पे यहाँ?
ओके सर.
Okay. Now any other doubt?
सर वो जो सर लास्ट में जो आपने एग्जाम्पल 3 में सेकंड पार्ट लिखा है, एक बार वो समझा दो एक और बार.
In second part, consider another B and K. Here, this is this sequence, but problem is you have no need to check that this is in N1, N2 increasing or decreasing, because first we want to check that all the element must belong to the parent sequence. Clearly 0 does not. It means immediately you can say this is not a subsequence.
Okay, so in the example 3 first part, it is in an increasing sequence. That's why we are not considering it as a subsequence.
Yes. In first example, all the terms are, we are taking from AK. All the terms of this sequence are presented in AK. Now we need to check increasing order.
Okay, sir.
But here in second, immediately you are saying that there is one element which does not belong AN. So immediately you can say this is not a subsequence.
And sir?
Sir, is every subsequence a sequence?
Eh?
Is every subsequence also a sequence?
Subsequence sequence तो होगा ही.
तो सर फिर उसको जैसा कि लाइक हमने जब सीक्वेंस डिस्कस कर रहे थे, तब आपने कहा था कि वो एक मतलब हर सीक्वेंस n का एक फंक्शन होती है. तो फिर तो सब सीक्वेंस को भी n का फंक्शन होना पड़ेगा. हम रैंडमली तो केवल इंक्रीजिंग क्या कहते हैं,
Increasing किसने कहा? I didn't say increasing.
इंक्रीजिंग वैल्यूज ऑफ n के मतलब.
Wait. I am telling. A and K. I took A twice K. Clear?
Yes sir.
This is the function 1/2 K. F K goes to 1/2 K. This is the function. K is a natural number. Is it clear?
Yes sir.
Now this is a sequence.
Yes.
Again, if we take A and K is equal to A to K minus 1. So again, F K you take function 1/2 K minus 1.
Okay, but you wrote at the side कि हम लोग जैसे हमने A4 ले लिया, फिर हम A9 ले लेंगे, फिर 813 ले लेंगे, ऐसे करके मैं किसी भी रैंडम पैटर्न में बस जो NK है, मतलब जो सबस्क्रिप्ट में NK लिखा है वो इंक्रीजिंग होना चाहिए, तो मैं वो ले लूंगा, तो उसको फिर सबसीक्वेंस नहीं कह सकते.
Subsequence because you will get always a pattern.
Okay sir, thank you.
Okay. Now I'm moving next. Now, if you are studying the subsequence, to come to one point in the picture, that convergent or non-convergent. So I'm writing that definition, convergence. So this is same as the convergence of a sequence, because every subsequence is also a sequence. So I'm writing the proper definition. Let A, I'm writing that will be better, AK, not N. AK be a sequence and A and K be the subsequence of AK. subsequence a and k converges to any real number a if same thing for every epsilon is greater than 0, there exists a natural number k and such that how a and k minus a is less than epsilon for all and k is greater than equal to k. So this is the convergence of it. Same thing. And k must be greater than equal to k naught. Now there is a theorem. This theorem is very nice. What says if a sequence an converges to a real number a, then every subsequence of an also converge to a. So it means if you have a sequence an which converges to a, so every sequence will also converge to the same point. Every, that is important. Every, if you are able to find any sequence which does not converge to a, then you can say parent sequence is not convergent. The proof I am doing, let epsilon is greater than 0 be given. Since this an converges to a, so there exists, you can write, you are taking k, this is where n, you take an, so it means you turn there exists n naught element of n such that an minus a is less than epsilon for all n is greater than k. Here you are, I am writing this is for your understanding only. Okay, this is one. Now always this a and k is greater than equal to k. Yeah, you can say like that. A and k, if you take, I can write in other words so that you can understand in a better way. Here, this is n is greater than k. Now, and k. I want to change the symbol actually so that you can understand in a proper way. Suppose this you take ak minus a, that is right, or here you should take n naught, or this is n naught, or this is k. This is same, or you can write this is, sir, you can write this is ak. I am changing, there is no problem because k element of n or n element of, I am writing because you can understand in a better way. So here ak minus a is less than for all k is greater than. Now I have this relation. Let, I didn't assume any sequence. So first I assume a sequence. Now let A and K be any subsequence of AK. So if this is a subsequence, so Nk will be greater than equal to K. That's why I took. You can understand in a way. That's why I change this K or N. So now here from 1 and 2. From 1 and 2, this A and K minus A will be less than epsilon for all Nk greater than equal to K. What I am doing, I am explaining NA. Suppose A and K be any subsequence. So if AN converges, you take AK, you can, I am changing this, AK converges to A, so this will hold K is greater than N naught. Now we know that if you take a subsequence NK is always greater than this K. NK is always, actually NK is always greater than N if you take AN. So here I write K. So here, if you replace K by Nk, so Nk minus A is less than epsilon for all Nk greater than is equal to K. Yeah, you more precisely you can say, or this is also true for N naught. You can also write N naught because Nk is always greater than K. So from here, A and K converges to A. So every subsequence converges to the same point. But main point is here. You can understand.
Excuse me, sir, but this will be only true for the decreasing sequence.
Who is saying?
As sir,
So, just wait. I am explaining. Just wait.
sir, n as
Just
nk
wait.
is
Just wait.
greater than equal to k.
Just wait. Just wait. Here, what is the meaning? Suppose I am taking N naught is equal to 2000. So it means A 2000 minus A will be less than epsilon above, or A 2002 minus A is less than epsilon for all. Now you are taking Nk is greater than equal to K. It means Nk will be either 2000 या 2005 या 2008 2009. तो सबके लिए ये ट्रू होगा क्योंकि ये सबके लिए ट्रू है, लेस देन एप्सिलॉन whatever be the value of Nk.
Okay, sir, clear, sir.
Is it okay?
Sir.
If in n is greater than n naught, if you have any problem, so take the number, then try to understand the inequality.
Sir.
Yes.
Sir, -1 1 -1 1 is the sequence, and 1 1 1 1 is a subsequence. But -1 1 -1 is not convergence, but 1 1 1 is convergence to 1.
Wait. Now, so it means what is the meaning of this? If you have a sequence, so converge will, every subsequence will converge to this. Now, I have a remark. What is the remark? If An, suppose you have a two convergent subsequence, have two convergent sequence A and K, and suppose AMK, whose limits are not equal, then sequence AN diverges. From above theorem, you can conclude this. Suppose you have a sequence and it has suppose two subsequence. So according to above result, both subsequence must converge to the same point. But if you are able to prove that limits are not equal, they are converging to different, then you can say parent sequence will not converge, it will diverge. Because previous theorem says both sequence, if AN converges, so both sequence must converge to the same point. Example, take AN, this sequence -1n. So you have two subsequence. We have two subsequence. That is, you can take A2K. This will be 1, 1, 1. You can write this is ANK, which is I am taking this. Here I am taking BNK. Suppose this is A2K -1. So this will be -1, -1, -1. This is. So see, A and K is a constant sequence. A2K converges to 1. Clearly, A2 converges to 1 and B and K converges to -1. So A and -1 की power है two convergent sequence, but they are not equal. They are not converging to same point. But previous theorem says every subsequence must converge to the same point. So it means you can say sequence AN diverges. So I think student who were asking the question, is it clear?
Yes, sir.
So that is. Now I am doing last example. Suppose you have a sequence AN. This is 1, 1/2, 3, 1/4, 5, 1/6, like that. Consider two sequence A to N. That is A and K. I am writing for your simplicity. I am writing this is A to K. So this will be, I think, 1/2. This is A2K will be. You are taking, sorry, I'm not taking this. Yeah, you can take, this is also 1/2. You can take. This is, I am taking 1/2 and it is coming from here also. 1/2, 1/4, 1/6. These are. Second, I am taking A and K. You can write A2K -1. This is, you are taking 2K -1. If you consider this is 1, 3, 5. So here I consider these two. Suppose this is M. Clearly, A and K and this AMK both are subsequence. Of AN. Here, but A and K converges to 0, but AMK does not converge. So by the previous theorem, the theorem says if AN converges, so every subsequence must converge. But here we have a subsequence AMK which does not converge. So finally you can say original sequence AN does not converge. So you can use result in two ways for proving divergence. If anybody has doubt, ask me. Any doubt? No? Okay. Now I am stopping the lecture.